Welcome to the sixth and final MPCNC live stream. Today, we're gonna cut some stuff. So yes, hi everyone who's already made it here. I'm hoping the announcement or the notification from YouTube worked. But yes, today it's done. So let me go over what I did since the last time we saw each other. Last time we ended off with the machine working mechanically, like it was moving very nicely. It was doing its entire thing. It was XYZ was okay, but let me see. So the first thing I did was I redid the zip ties on the belt. So this is the X-axis belt. So I do have the long loop on the negative end, and then I've got a really short loop, as you can see back there, on the positive end. Because this carriage, well, if I had the board off, because this carriage has more weight or more material towards this is 0 over here, 0, 0. Because this has more material towards the 0 side, you can have the loop, you can have a longer belt loop on this side than you can have on that side. So this carriage actually goes further towards this end than it goes here. So this side is static, doesn't have any tensioning. This side has that long belt loop that allows me to tension the belt. So there's that little zip tie end that we can use to tension the entire thing. And the same for the y-axis on both sides. That's mechanically what I did. Did I do anything for wiring? I don't think so. So that's all stayed the same. No delayed notifications, perfect. The other thing that I did is I went into the, what's it called, do it configuration. And I did make a few mistakes last time. First of all, I used M501 for saving stuff, which is actually reading the configuration. So that didn't actually store. To save any changes you make in the, you're seeing my back there on the B camera, nice. To save any changes that you make in the web interface or just do in real time, like changing whatever, steps per millimeter or acceleration values, you send M500, that saves it to the config override, and then M501 reads that back. So I've redid that. I did slightly increase the currents. So if you want to follow along here, the great thing is with Do It, you just can go over into these into the system editor and you can jump into config.g. So what I did is I set the motor currents. That's what they used to be, 1500 milliamps on X and Y and 800 on Z. So the C axis didn't really do much. They're now at 2 amps and 1.5 amps for the Z-axis. Remember, the X and Y are split between the two motors on each end, so it's effectively like 1 amp for each motor, which is still plenty strong. Like if I hold it right here and move the machine, then yeah, the machine moves and the motor doesn't skip steps. So I think that's plenty strong. So I can slide this thing over the table with the machine moving itself. So I changed that. What else did I change? Yeah, I tried disabling the heater, but that command actually doesn't do much. Then what you actually need to do is down here. So M563, can I zoom in here so you guys can maybe see that if you're watching on a smaller device. M563, by default it has P0, D0, H1, F1. So the H1 it's connected to heater 1 and fan 0. It's cooling fan 0. So if you have a hot end cooling fan, you'd have that temperature you'd have that temperature controlled like that. But since we have neither, we can just remove those arguments, and that actually removes the, hey, temperature's out of range warning right there. What else? Yes, and these last two commands, CNC mode and allow moves. Thank you to Karen Evans for that hint. So M564 S0H0 allows move beyond axis before home, and M453 sets it to CNC mode. I'm actually not sure what CNC mode does, but it works. It lets the machine, I don't know, the machine works as is. So that's what I changed. And hopefully today text-to-speech is working.
Thanks for inspiring me to finally build this. I'm printing the parts as I type this, and I'm working through ordering the hardware. So many decisions to make.
Yeah, thanks for the $10, Bill. Now, for the parts decisions, I think I'm actually pretty happy with the choices I made for the spindle so far. We'll have to see how well it cuts. And all the other stuff is actually working out rather nicely. One thing I'll have to say is use some decent zip ties. Don't use the cheap ones that I used initially. But yeah, thanks for that tip, and great that you're following along. And thanks for the 20 Danish crowns, the rep. What's my favorite build? My favorite build as far as printers or machines go? I don't know, I've not done that many builds on stream, but this one so far has been working out pretty nicely. I do still want to build that original RepRap Salesmantle, my very first printer. It's like a 10-year-old design, but it's a historic design for sure. Okay, but let's get back into this. So we've got CNC mode, we've got allow moves before home, which basically just means it's still got the warning up here where it says some axes are not homed. And if you jump over into machine control, it still says the following axes are not homed. But for example, Y is at 0, and we can actually move below 0. So I'll just move that towards the home position. And we can see that's at -140. So I guess CNC mode also disables these soft end stops, because typically you wouldn't be able to move below the 0 position. But yeah, that works beautifully. And as you can see, because we changed that tool, we don't have the heater current active yada 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 settings here. The temperature chart is still here. We don't really need that, but I guess there's no real way to remove that. Maybe someone has a tip of how to get rid of the chart, but really we don't need that. So I want to cut two things today. Let me see if I missed anything in chat. Nah, we're good. Okay. I want to cut two things here. First, I want to start out with a simple cut in wood, because wood is a bit, is not as hard on the machine. And then I want to mill a motor mount plate. I drew that up real quick because I wanted something that wouldn't just be a test cut that I throw away. I wanted something that would actually be usable. Out of this precision milled aluminum, this is 6mm thick. It's actually what I made the bed on my Service Reborn Delta out of. So this is an aluminum grade that I think is suitable for cutting. We'll see how well that goes. I think I'll go easy on the machine because it's turned out not to be the most rigid thing ever. I think it's like suitably rigid, but again, it's printed parts. So aluminum, we'll try. I misplaced my WD-40, which I was going to use for cooling or for lubing up that cut, but I don't know where that is, so we're going to cut aluminum without any cooling. We'll see how well that goes. If you break an end mill, we break an end mill. So that's going to be it. But these 1/8 inch end mills are actually quite affordable. So these are just the standard, there's the focus. Standard 1/8 inch carbide. I don't know how much carbide's actually in these end mills that you can get from AliExpress. It's actually pretty good. They're pretty sharp. They're 2 flute, upcut bits. They're nice for the price. I mean, I think these are like 50 cents a pop or so. They're quite cheap. 3.175 millimeters. Yeah, it's just a pain to say 3.175 millimeters each time. 1/8 inch is quicker because it's an imperial dimension, so I'm going to use the imperial measurements for that. All right, you guys still enjoy looking at my back? Nice. So cam, yes, we're going to use ESTL cam, ESTL cam. Fusion would be the better choice, I think. Fusion is just a much more powerful cam package, but I don't know how to set that up for a fresh machine. I've used it with machines that already had the profile in there, but setting a machine from scratch, don't know, never done it. I do know how to use EstelCam, and it's kind of machine agnostic. It doesn't really care about which machine exactly you're using. So yeah, there's also, I mean, there's also lots less cutting parameters and stuff. So I'll start with that, but just know this machine can run with anything. It just, you know, it's a do it board. So all it needs is G-code to run. So there's the do it. Anything that board can understand, you know, the printer will run. So any movement commands in any format that the do it understands, you can do. So Uncle Phil is using EstelCam? Possibly. Right, so let's start up EstelCam. So ESTLCam is a, it's not free, it's a shareware program. So I did buy like the EstelCam 8 license at some point, but there's like a new version every, I want to say like every 4 or 5 months. And the license only works for the current and the next version. So I could be using EstelCam 9, but then I'd have to upgrade or buy an entirely new license. And that does get expensive over time. So that it's probably like a 60 euro to 100 euro a year recurring cost if you stay updated, or maybe a bit less, I don't know. So what we're gonna do first is we're gonna jump into setup. Basic settings. So English, length unit DXF. The only appropriate unit is millimeters, and for STL as well, millimeters. CNC programs are also in millimeters because that's what the RepRap firmware does, and in EstelCam as well. The feed unit for programs and that's for the output. So that's what's being written to G-code. I believe that's correct. And then in EstelCam, that's the ones you see up here. You also set those in millimeters per minute. Clearance plane, that's how far the bit moves up between cuts. So the machine's going to make a cut out one area and then move up a certain amount and then move over to the next area. That clearance plane is how far that bit moves up. I'm confident that 2 millimeters is going to be enough. Conventional workpiece topside, yeah. So origin. Let me talk you through the entire origin thing real quick. So say we have this as our blank. So 0, 0 is down here. Actually, let me remove these driblets. This down here is 0, 0 somewhere. So X positive, Y positive. So we're going to say our origin in our CAM program is here in this corner. So typically X positive, Y positive. This is the area up here. I should probably flip this camera 180 degrees, but this is the area up here that's going to be cutting. So our origin point for most CNC programs is going to be at the upper edge of that blank. So that's our blank, X positive, Y positive, and on the top side of this part. That's typically where you set your home point. Now you can also set it to your plane. You can also set it to your workpiece, but the only difference is basically what you tell your firmware before you start that cut. So you can change that 0 position however you like. It's just I like to have it on the top side of my workpiece because I know how thick this stuff is, I think. And yeah, then on the positive end of that, that's where our cut is going to happen. So Z-axis origin workpiece top side. That's what we're sticking with. And I'm telling it, it's Marlin. I think that just changes how the G-code is output. So CNC programs, same thing, length unit. We're going to change that to G-code real quick. So that's just going to create .G-code files. I'm not going to use our commands, though I think Do It would understand it. Yeah, so I think that there was something that we needed to change, but I think this is all good. If somebody sees like an issue with this, let me know. I don't think we actually need this. Don't think we need this either, but G90 never hurts. And then program end, spindle stop, it's fine. Okay, so coordinates, that's all good. It's funny that you can set scaling for each axis. If you set up your steps per millimeter wrong, you can correct it in software, which is just totally, I don't know, you should set your machine correctly. Yeah, G0, G1, that's all good. Formatting, perfect. So formatting repeat F. Hold on, thanks for that tip, Ryan. Repeat F. Repeat something. Commands. Repeat. Yeah, the repeat checkbox is in there. So that's good. I don't think we actually need that. Cool. What am I using to switch cameras? So many cameras, so many perspectives. Again, gear is all linked in the description below. This is a Stream Deck, Elgato Stream Deck. Really nice little thing. And software is OBS Studio, plus like 4 Panasonic cameras into a capture card. So that's all set. Now the first thing we're going to need to do is to define a tool. So this is going to be our standard 1/8 inch tool with a diameter of 3.175 millimeters. Our Z plunge depth. So yeah, there is the explanation. Basically, the tool is going to create several passes as it cuts out an area, and it's going to move down a bit every time. So with wood, with like a softer material, you can plunge in pretty deep, but with aluminum and a machine that isn't super duper rigid, you probably need to reduce this. So I'm going to set this to 5 for now because we will be cutting wood first. So plunge angle, plunges vertically. Yeah, we do have, so the difference is with these bits, this is a bit that is end cutting, that cuts on the end, so you can use it like a drill. If you don't have that, you will need to plunge pretty flat into the part. So, right, that's good. Feed rate. Okay, so I did use some cut calculators for aluminum, for how you should be cutting aluminum with the feet per tooth and the linear cutting speed. And it turns out with a 12,000 RPM spindle, an 1/8 inch bit, you can actually get into like correct cutting parameters for aluminum. So we're getting roughly 120 surface meters per minute. 120 meters per minute surface speed on the cutter, which is actually within, it's on the low end, but it's okay for aluminum. So aluminum should work. And now for the feed rate, it has to get up like a normal feed per tooth. We're doing 600 millimeters per minute, which is 10 millimeters a second, obviously. And then for the Z feed, I think we should lower this slightly. Spindle speed doesn't matter because we're not controlling it anyways for now, but we're just going to set it to 12,000. So that's for roughing or for normal cutting, and then the yellow one is for finishing, because you can use the same tool. You didn't used to be able to do that in Islicam. You can use the same tool to do a roughing cut, and it's going to use the orange parameters over here, and then do a finishing cut, and it's going to use the parameters there. So because we're only doing, are we going to be doing finishing cuts, finishing passes? I don't think so. But yeah. Cool. So that is the setup for the bit. And it's actually it's a 180 degree tip. So that would be a 90, having like an engraver bit, but we've got a flat end that's 180 degrees. Cool. So Ryan actually pointed out that doesn't do it expect feed rate in millimeters per second? Ooh, I don't think it does. Feed rate in G-code I think is still in millimeters per minute. Ryan pointed out it's in coordinates. Repeat F, that keeps the set speed behaving. So let's try and find that. So setup, CNC program, coordinates, and then repeat. So I guess this X, Y, Z. Let's repeat that. If anyone knows, then it's Ryan from V1 Engineering, because he actually designed the thing. And I'm guessing he's already used a Do It With Us. So I did prepare some DXF files, which is the standard. I'm not showing you my screen because I'm going through my Google Drive and stuff. I did prepare some DXF files, which are just a 2D or 3D vector file. We're using 2D vectors, and that's basically the standard format for any sort of 2.5D mill, which this is. So we're going to jump into test cuts, and I did prepare two. I did prepare this one and this one. The motor mount's going to be the one in the in aluminum, and then the BY crown. Somebody was saying, hey, you gotta cut a crown. I don't know why, but the only appropriate one is obviously the crown of the Bavarian king, which is like, I don't know, 1600s, something like that. I just sketched this off of the Wikipedia graphic for that crown. So now we have this crown in here. So we're gonna be cutting that into wood or in wood. Let's check the grid. Grid's over here, so let's do like 10 by 10 millimeters. So this is, how large did I sketch this? 5. So this is a bit over 10 centimeters. This is like 10 by 8 or so. So a decent size cut. Now the would it cut Korean? Yes, it's probably does. So the crown isn't meant to be cut. It's a crown. I don't know what's up with that crown. So we have a few different choices. Well, first of all, let me walk you through this. So you may have noticed that there's an additional piece of wood, of particle board on the bed. Because I don't want to actually cut into this MDF top sheet, I don't want to use this as my waste plate, because we are always going to cut slightly below the part, just to make it all the way through. And that's not always going to be perfectly accurate. So I am going to put an additional layer of material that is going to be cheap, disposable, and easy to exchange or easy to swap out on top. So this is just, particle board, the cheapest stuff you can get essentially. So that's going to be my waste plate, and we will be cutting into this. So all I'm going to be doing is screwing it down into the wooden base with these screws. If you I may be able to add that I may be able to add the DXF file to my website under the sorry about that, under the parts list, so anyone can download that file. Again, it is based on the Wikipedia vector file or graphic for that crown. It's not a nice design or anything, but I'm happy to share. What did you think about the M8 threaded inserts I tweeted to you about? Oh, I think I missed that tweet. I did see a tweet about power supply mounting and about having like little brackets, but I didn't see that. Good question, Sebastian. Did I do some basic bed leveling? Now, the thing with the MPCNC is we did do bed leveling essentially. We did measure each of these corner pieces, making sure that we did level each of these corner pieces, essentially making sure that each of the corners was at the correct height. Now, I can assume as much that this bed is flat, and looking over it, it is probably within half a millimeter. It's slightly bowed, but it is pretty darn flat. And all the material we're packing on top, like the particle board, is also pretty flat, as well as our workpiece. So I think for simple through cuts like this that we're doing, we can just assume that it's flat. So yeah, we did level it. Again, yes, we can just chuck a big router bit in here and just mill it flat. That's an option, but for now we don't need to do that. But we can. All right. Mill down a new surface with an 1/8 inch router. Yeah, that's going to take like half a day. So for materials, I'm going to have you guys decide what we actually cut into. We have 3 different options that I kind of grabbed. I've got this piece of, oh God, what is this? It's pine, right? This is pine wood. It's gonna smell amazing. That's 16, 18 millimeter board-ish. We've got this, so this is solid wood. We could also cut this IKEA door, kitchen door. This is an MDF core with white paint on the ends, also roughly like 16 millimeters or so thick. Maybe 15, I don't know. And we've got this thinner, like 6 or 5 millimeter, I think this is HDF. So this is a finer fiber material, or a harder fiber material than the store. So I'm gonna have you guys decide what we're gonna do. Now the pine, obviously, before you vote for that, the pine will kind of flake out. Because this is a more of a directional fibrous material, we're gonna be cutting through this, and it's probably gonna come out with a rough surface, but I mean, we can try. Pine, 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 pine. Now I do also have softwood. I do have what's it called, kumaru, which is a beautiful redwood, but it's I think it's a bit too hard to start with. Hardwood though cuts beautifully. So right, MDF is bad, dust is toxic. Okay. Did nobody say aluminum? We will be cutting aluminum in a second, but for now we're gonna start with wood, simply because it's easier, and I like the easy things, at least to get started. So let me grab a few screws here, because it looks like we're gonna be using the pine. I guess these are fine. Aluminum, please. Yeah. We'll get into the aluminum. So grab a few screws. Now the nice thing about not having an appropriate camera angle, but this one's good enough. Hoping I didn't whack that out of alignment. The nice thing is, because this is an open frame, we can just have stuff hanging out the side. We can just, you know, essentially have this board stick out the side. And I know some people were cutting stuff on the MPCNC where they cut it in multiple passes, where they just cut one bit, then moved it through the machine, and then cut the next bit. So we can do that as well, but for this piece, it's just really convenient that we can just have it stick out the side. So I may need to pre-drill this. I'm hoping this is good. This is good. So about that length. Let's just cut it over, or mount it over here. Oops. This wood is rather soft, and it's also pretty, I don't know, greasy, rich with resin, so it is kind of sticky. Mask for dust. I do have a vacuum here to suck up most of the dust. So we've got it screwed down over here. We don't have any screws in the wasteboard underneath where we're going to be cutting, so we're really cutting in this area right here in the center. So somewhere down here, we're going to set the zero position. Do you have any downcut bits? I do not, but I don't think that would be a rather smart idea, because it's just going to be filling up that cutting channel with dust, wouldn't it? So this is 18 millimeters thick. That's something we will need for the that's something we will need for the cam in a second. Right, anything I missed in chat? Nah. Okay, cool. Let's do some cam. So, nice thing about Estelcam, so just, I think somebody mentioned that, oh, masking tape. We'll just try it. Somebody mentioned that this wasn't really designed for cutting, and it's not. Like, this isn't designed for cutting, but it is cuttable. Let's put it like that. So, nice thing about Estelcam is it's kind of really simple. So, you just select the outer contour, select part, which cuts on the outside. Toolpath depth, ask later, and we're going to be using the 3.18 millimeter or 3.175 millimeter end mill. Let's add, should we add some holding tabs? Nah. So toolpath depth, it's going to ask when we export this G-code. It's just going to ask how deep the entire thing is going to be, and it's going to set all the toolpaths that we create to that depth. Cool. So that's that. Next, hole. We can do a hole here. Now you can see that there's like not enough space for the router to make it through, so it's just going to cut like a weird wiggly shape, but it's better that it cuts it than not cutting it. We're going to do a hole here. We're still selected on the right tool. We can do one here. I don't know where this cuts on the so far on the outside, but I guess. And there we go. That's it. That's the entire can basically. Because we did set up our tool right there, that should be good. So please enter the desired cutting depth. We're going to go for 20 millimeters because we're doing 5 millimeter step down, which means it doesn't matter whether we do 18 or 20, but 20 just makes sure we cut all the way through. So cutting time 6 minutes 25, and we can actually look at our toolpath in 3D. We can play it, speed up, yeah. So Istelcam kind of intelligently rearranges these cuts, so it does the inside cuts first and then does the outside contour, because if you do the outside first, then the entire part on the inside is just going to be floating around. But like that, it should be all right. Needs a smaller bit diameter, yeah, not for the first cut. Now I do have, where's my box? I can actually show you guys what I have available here when it comes to bits and stuff. So that's my bit box. Yeah. So I've got everything from, these are drills from 0.3 to 1.2 millimeters. I've got, these are engraver bits with a 15-degree angle. These are 2 millimeter end mills. All these are like super cheap. Like you can get a 10-pack for like $6 or $7. These are, I don't know, I have to measure. More engraver bits with a less sharp angle. Then I do have some 0.35 or some 1 millimeter. These are 0.35 and 1 millimeter end mills. So that's like really nice detailed stuff right there. You can see how thin that tip is. You can probably not see it at all. But yeah, for now, I'm just sticking with the standard 1/8 inch end mill. So let's go chuck that up. And especially in wood, because this is just a generic cutter geometry. This isn't anything that's like specific for wood or for, well, I guess it's kind of specific for metal. That's what you use it for. But for that, this is probably all right. Quit stalling. Yeah. People were asking about that. I'll just get in there. Come on, ER11. Why are you? So there you go. The ER, that's what that ER11 collet looks like. Now the ER collets, this is the collet itself that is made for the size, and you can just exchange these and chuck up different sizes. These need to go into the nut first, like that, because then when you unscrew it, it actually opens up this aperture right there and lets go of the tool. And yeah, let me just make sure the stick out is all right. There we go. And then this has the matching cone shape in the spindle. And we need to just lightly tighten this up. What is this? That's 14, and that's a 16. So, no, that's a 17. Just some light tension, doesn't need much. Oh, the stick out, yeah, we're cutting through 18 millimeter material. I mean, the stick out of the tool isn't the problem. Like the rest of the machine is flexing way more than that. So that's that. Send it. You can override feed manually. Right, I do need some hearing protection because this is going to be loud, and also headphone users, you will probably suffer. Well, but let's confirm this. So I believe save CNC program up here. So we just save that right there. Cutting depth, again, 20 millimeters. That's good. We get the same simulation, 6 minutes 25. Okay. And then we basically, let me make sure I'm not showing you guys anything that you shouldn't see. Right, so what we do is go over into our MPCNC, into our Do It web interface. We grab upload G-code files, we upload the BY crown. That's that. Close. Now, as you can see, the coordinates are still kind of all over the place. So we'll need to move our end mill to the home position, or to the 0 position of our work. So I'll make sure none of the cables get caught. That is looking all right. Roughly there, and then we just need to move down ever so slightly. That looks good. Maybe a bit further up. There we go. We're cutting deeper than we need to. So yeah. What's the thing with, oh, this end mill's gonna die? This end mill is probably this. I mean, this end mill's gonna be fine. It's gonna be all right, right? I don't need an extinguisher. I've cut wood before. It's not gonna blow up. So we're at the 0 position. We're basically just gonna tell it this is 0. Oh, X is 0 too, and this is 0. So that's our 0 position right there. Now all we need is a spindle that's running. And we need the BY crown. Do we get a start button before I click this? I think we do, but first, spindle on, hearing protection on. Guys, it's gonna be loud, I'm sorry, it's just, where did my hearing protection go? Not back here. It's gonna be loud. It's gonna be fine. Yes, it is going to be fine. Wanted to use the cam in Fusion because I think the easel cam is easier to set up. Whew. All right, vacuum on. Spindle. Spindle on, turning at 12,000 RPM. BY crown. Do you want to run BY crown.G-code? Yes! It's cutting! Sewing it! Ah! We got vibrations like crazy! But it's cutting! We have chatter like crazy! We have an option for speed factor. I'm going to turn down the speed factor to 67%. That's better. That's at 67%. Stop. This is fine. This is fine. Absolutely fine. Oh. This ain't fine. Bring down the speed a bit more. Wear a mask, probably a good idea. Yeah, so the cut is about 2 millimeters wider than what it should be. All right. I'm stopping this. Okay. So that was quite something. Now let me scoot you guys back in here. So headphone users, you can turn up the volume again. There's our cut. Now it is obviously this like flake out. I warned you guys about that. That was going to happen, but the cut is actually much wider than it's supposed to be, because the entire thing just vibrated around. You can kind of see it. Just me pushing the carriage there. How much that's moving the end mill just by hand. So something broke. No, nothing broke. Nothing broke. Something was vibrating here, and I'm thinking it's a combination of the fact that it's 3D printed parts, the fact that it's belts that are rather long, the fact that the belts themselves are fairly cheap ones and not like gates, which are about 2 to 3 times as stiff. So something is flexing and acting as a spring. Yeah, and you can actually see how much the belt itself is flexing. So I'm just grabbing this carriage up here and pushing it around. And with the motors holding, you can see how much that's moving. So that is just the belt. And the zip ties on the end. That is just that. So there is a lot of softness from these belts, definitely. Too deep. So yeah, I can try less cutting depth, obviously, because we can set that in. Where's our ISTILChem? We can set that in ISTILChem pretty simply. So there, and let's go down to half as much. Let's do 2.5. I mean, there is the option of doing trochoidal cutting, which I believe this stuff back here is, which lets you use the full length of the bit, because as we reduce the cut depth, we only use the very tip of the end mill. So if we do 10 cuts at 1 millimeter, we're going to be putting twice as much wear on the tip of the end mill than when we use like a 2 millimeter depth of cut, because that entire load is going to be spread out over more of the area of the end mill, and you do want to use as much of the end mill as you can. So let's try and redo this with 2.5 millimeters, half the depth of cut width, which should be half the amount of load on the end mill. Because I mean, yeah, it's not. Also, the zip tie is stretching a bit, yeah, but only in one direction. I mean, I can slightly tighten this up more, but these belts are already, like you can see this, these are already quite well tensioned. Aren't lead screws better than belt because of resonances? Yeah. No slotting, full length end mill. Yeah, so just to explain, the reason why I went for 5 millimeters in wood is because I've done that on the Mendelmax CNC conversion. The Mendelmax CNC can actually chew through MDF or through wood, through solid wood, like crazy. Like the spindle, I don't think is very happy about it because it's right at its limit power-wise, but you can send that thing through MDF with like a 10 millimeter depth of cut, just full blast, run it through. It does it. It's not happy, but it does it. It doesn't resonate as badly as this. But it's also like a third of the size in each axis. So just pointing that out. That's why I went for that. Trochoidal milling requires a rigid frame. I believe that's actually the opposite. Trochoidal milling is meant to not require a rigid frame, as far as I know. Okay, but let's just re-export this. Save. We changed the depth of cut for Z. I'm thinking is it still on the right cutter? Yeah, it is. We can also select each of these tool paths and select a different cutter for that. So save CNC program, by crown half. We're doing 20, and as you guys can all see, if you speed this up, now it's doing a lot more cuts, and our cutting time is also 12 minutes instead of 6.5. Alrighty then, maybe we can speed up the feed rate if it's all right. So we did save it, which means now we jump over into our Do It interface, G-code files, upload, half, crown half, there's that, so that's ready. Is the tool spinning the correct way? I did check, yes I did, so it's probably going to be really hard to pick up on camera. But if I slightly spin this up, well, I have to actually show you guys, but yeah, this is spinning the correct direction. It is really hard to pick up, but yeah, it's spinning clockwise the way the cutter is meant to be cutting. So I am 100% sure of that. So let me move. So let me actually, so we did remember the X and Y home, we didn't lose any steps, but I'm just gonna set the X position to -20 or so. Wait, can I not set this to negative positions? Yeah, I cannot. Why can you not? That's a bit of a problem. So I'm just gonna move the bit over so we get like a new area of cuttage. We get an untouched area of the wood. Go back to that. And basically now we're ready to cut. Vacuum on, spindle on. Guys, trust me, the spindle is turning the correct direction. I can put a bit of tape on it, but it's correct. So do I want to run that? Yes, in a moment. Headphone users, please beware. This is gonna be noisy. Oh, just the spindle itself obviously isn't that noisy, but here comes the vacuum. So yes. We're still in the print. Cancel. That does look a bit better. I'm still feeling a bit of vibration in the base, but it's cutting. Yeah, it's still chattering. Oh yeah, it is definitely chattering, but it's not as violent as before. And it's always when it's climbing against the, right there, when it's climbing against the grain. Yeah, right there it did chatter a bit. I mean, you gotta consider this is a pretty small end mill bit. It's not a, oh yeah, yeah. Now it's chatting even more, so I'm guessing because the Z-axis is now more extended, so the lever between where it's kind of anchored and where it's cutting did extend a bit. It may change the resonance frequency. Yeah, I'm not happy with that. I am not happy with that. Okay, I did cancel that again. Let me check. The end mill is still pretty sharp. Still feels good. I'm going to be switching the wood. I'm going to be switching over to just regular old MDF. Or actually, let's use the HDF because that's not as thick. That's not going to take as long to cut. So I'm going to be cutting this. Might be a bit more consistent. I'm just not. I don't think I'm happy with the pine. Let's try HDF because I feel like I know that's going to cut better. So Y plus 50, a few times. Let's move it out of the way. Think about how fast you will go hand routing. I mean, you can actually see this very material. See, this very material I've built my dashboard frame out of, and I'm still waiting for the video to go up. I did literally hand route this right there. That's a bevel bit, whatever. Right there, and these are really clean cuts. Like these are pretty nice, pretty clean. No, well, a bit of chip out on the end, but these cuts are like super nice. And you know, this is just plunging in, going out, clock, really no accounting for I gotta go slow or anything. We can really pull through this stuff and get good cuts. So that's, I mean, hand routing is not a problem with that material. So let's grab some smaller / shorter screws for this. Getting a long mill? Not yet. Ryan suggested he tighten some stuff. Let me scroll up real quick. Half a turn on the 4 M8x65 bolts on the gantry. So I'm guessing that's these up here. I mean, there's no slop in these. Right here, I'm guessing that's the M8x65s. I can tighten that up, yes. I don't think it's actually going to do anything, but let's try. Before we start cutting the HDF. So that goes in here. Half a turn. Half a turn. There's two more down here, so I will see if I can get to those. Half a turn. Okay, half a turn is a lot. But there's no significant resistance. I mean, this one does have some resistance. Don't get frustrated. I mean, you can see how, if you watch my previous streams, you know that I tend to get frustrated with CNCs, but so far we're good. We're good. So I'm hoping I can somehow get a wrench in here because this is all pretty tight down here. I like that. That works. So in the back from below. And let's give that half a turn as well. I mean, that's not how you're supposed to use a wrench, but and then there's one more back here, which I have almost no way of getting to. Kind of fiddling in the back here. No. I'm guessing that's grabbing? Yeah, that feels right. Maybe the bit is though. I'll also use a fresh bit for this next cut, just to be sure. So half a turn on this one as well. Okay, now let's swap this end mill. That was a 17 and that was a 14, right? Yes. So the first half turn loosens it. This is still tight. By the way, never grab an end mill by the sharp bit because the job of an end mill is to cut. And this is basically, you know, It's basically something that's going to never focus, but this is basically a piece of blades wrapped around the shaft. So always try and undo everything else as much as you can first before you grab onto that. I have cut myself on these end mills, that's how I know. So usually if you undo it a bit more, there, now that's blurry again. Come on, there you go. So now there's a bit of resistance. Now if I undo this a bit more, there you go. You saw that just undid it and this thing just comes out quite easily. Nice. So this one's going into the maybe try at some point later pile. And we'll grab a fresh, never before used 1/8 inch end mill. I'm thinking this is the exact same type, right? Yeah. Looks about right. Okay. Going with roughly the same stick out because again the mill itself, or the end mill itself, was not really flexing. I don't want to tighten that more than that. It's an ER11. It's not a massive chuck, and this is way more than tight enough. If I push here, everything else flexes first before the bit itself flexes, and it's not like these ER collars do bite fairly well. So let's get this HDF tightened down, and I do need another Torx bit. Increase spindle speed. Thanks for the tips, Sidan, but we're already at the max. We're already at 12,000 RPM. That's all this brushless spindle will do. That's all it's capable of. So let's tighten that down there. Okay, and now we have this area right there that we can cut. What I've actually thought about is, because this is just essentially, this is a brushless motor, right? This is just a three-phase brushless DC motor. You don't have to run this off of the standard driver. You don't have to use the, what is this type? The WS55180, you don't have to use this driver. You could actually just use an RC car speed control. I don't know if that's going to get any extra RPM, but maybe if I can find one that does like fairly high voltage input, I may be able to get some more RPM out of the spindle, because if you're not loading it up to its limit power-wise, then I don't think it's an issue giving it some extra voltage. And voltage is what drives your RPM up. That looks about good. So let's get this down a bit further. So we're right about there. So Z -5. There, that looks good. So now let's reset this position. 0, 0, 0, 0, 0. It's interesting that it resets all the other ones as well. Whew. Linus Tech Tip sandal. No, no. These are better. These are ESD safe Birkenstock. Linus doesn't have those. Also, Linus has the sandals with a strap around your what's the name? With a strap around the back. These are so much better. Like, All right. We need a new G-code. We do need a new G-code because we have changed the cutting depth. So basically all we're doing is we're saying save CNC program. and we're saying we're doing we're using the same cutting depth, 2.5 millimeters, and we're saying we're doing 6 millimeters. So that's the current one, and we're cutting 6 millimeters down. I think this HDF is 5 millimeters or so, but it's going to do one top pass, one middle pass, then a small pass on the bottom. So let's do that. Close. Do we still have this? Yes. No. Start another. Oh shit. That kind of went in too deep. I thought start another was just, oh, I'll let you pick another one. No, that's actually, hey, I want to start this thing right now. Okay. Okay. Happens. Just rammed it in ever so slightly. Can't see that, but we need to power stuff up first before we start a cut. So let's do that. Not even a confirmation window. Nope. I think we may have lost a step on the z-axis, but it's fine. It's still just barely above the surface, where it should be. So, headphone users, we're going in. G-code files, 6 mil. Yes! Send it! I mean, it's not like this stuff is the greatest cutting material ever, but at least we don't have any chattering. At least it's cutting more cleanly. Somebody's saying I don't need to shop vac the entire time. Well, I just like to get as much of the dust out and sucked up before we, before it starts floating around in the air, because there is quite a bit of air flow coming down from this fan top on the spindle right there. That's actually blowing quite a lot of air down over your part. I'm hoping you guys can still kind of understand this, but yeah. For wood you need a 2-flute bit. I am using a 2-flute bit for this. Still seems kind of fast. I don't know, it seems kind of slow for me. Because remember, this is a pretty soft wood. It's MDF, HDF, something along those lines. I think it's HDF. It's marketed as carbide, this end mill, but you never know what the Chinese put in this stuff. They're saying it's solid carbide. I'm okay with believing that. Too slow, rubbing instead of fighting and cutting. That's what I'm thinking too. I mean, that the cut, if you look at that surface there, to bring you guys in a bit closer, it looks okay. Oh, we're still at 47%. We're at 100%. That's why. We're still at a slower speed in the do-it control. There we go, that's 100%. And so far it is looking good. I mean, yeah, we could discuss like cutting parameters with all this flaking up right there, but the cut itself is working. Keep your freaking hands away. That's like Russian roulette, like doing that, cutting between your fingers. By the way, do not do that at home. These are my fingers, my wrist, but do as I say, not as I do. So, since this is going so well, let me try something that is going to make it go significantly worse. I'll tune up this, or crank up the speed a bit more. I'll go to 150%. There we go, 150%. I think it should work. Yeah, there we go. That sounds like a real cut. Oh, it's chattering. It's chattering. Let's go back down to 120. That's better. Okay. So 150 was definitely too much. I'll stick to 100. So the crown is taking shape. Well, let's show you guys perspective where you can see absolutely nothing. And you can see, if I take away my vacuum for a second, you can see how much dust that's kicking up, and that's just going to spread all over the studio, which I do not want. So because we don't have any tabs in here, this last pass is actually going to be quite scary, because we're going to have nothing holding this piece down. I'll use my finger to hold it, and then when it gets, or at least once it goes up to like this area up here, because it may wobble around a bit too much. Way too fast feed rate, way too slow feed rate. I don't know what you guys want. Like, everyone keeps saying something else. So I'll just drop my fingers down there and kind of pull this crown away from the cutter, because we don't want it getting stuck. There we go. There is our crown. Yeah, everyone in chat is an expert. That's something that I did notice as well. One thing that I do want to try out real quick, because this does seem to be rather noisy for you guys. I'm going to be switching to a headset mic, because that will cancel out the background noise a bit more. Brand new Rode HS2. That's going to cancel out the background noise real good. I'm going to have you look at this crown real quick while I change mics. There we go, and you guys can discuss whether it's a good cut or a bad cut. I'll give you a bit of a side perspective. There we go. 1 second, I'll mute myself real quick. It's definitely a cut. Yeah, I can agree with that. So I'm hoping that audio is okay. It probably sounds just the same to you guys. It may be a bit louder, a bit quieter, but it should sound pretty much the same, I'm hoping. Let me know, guys. It's quieter. It's quieter, it's quieter, it's quieter. I can crank it up. Hold on. I can crank it up 10 decibels. But I'm thinking now it's even louder than before. Very quiet. Okay, 15 to 20 quieter. I cranked it up 10, so I'm seeing it's a bit louder than before. Should be all right. Okay. So headset mic. I now look like that telemarketer guy with the ShamWow. But yeah, let me just check out this cut. It's interesting that the last cut is still creating some fuzzies. So if you look at that profile, there we go. This is the top, that's the back. Hurting ears, sounds good. Slap chop, yeah. It's a cut, right? It's the first cut of this machine, and it did cut. Like the backside is actually pretty clean, obviously, because it did have the waist plate where it was pressing against. But yeah, this is all right, I think. This is pretty good. The camera keeps focusing on the end mill. So, shall we move on? Shall we try some aluminum and actually wreck this machine entirely? And the camera just turned off. That is fantastic. Camera, why do you keep turning off? A bit more on the belts. So Ryan is asking about the belts. Ryan from V1 Engineering. Now, these belts, are they tighter than on a 3D printer? Yes, they are. So if you move over here, they are tighter than on a 3D printer, definitely. They are as tight as I want them to be. Did tightening these bolts up here, these M8x65s, help with the chatter? I don't think it did. I think what helped with the chatter was the different material, was the fact that it's MDF and not the somewhat highly directional pine board. So I think that made the difference. I don't think, because I mean, if you look at how much this tool deflects, just from my finger here, how much we can move that around, it's still like not particularly rigid. Just lost a step because the motors are powered down, but it's still like very easy to move around. So not super duper rigid still. And I don't think that's ever gonna change until maybe I change out the belts or change the way the belts are tightened or something like that. But yeah, let me now print a stand for the crown. Let me try aluminum, shall we? Let me do the stupid thing. So, but first we need to unmount this piece of, where do we move? No, we move that. Let me first move that out of the way and mount a piece of aluminum, because why not? It adheres to cut at 0.2 depth at about 100 millimeters per minute. That is super. That only. I don't think that's cutting. I think that is actually more rubbing than anything. And if you're at 0.1, wow, I mean that's gonna take forever. Mount it as high as possible. So just add more spacers on here. Add another piece of material. I can try. I can mount it on top of the pine board, but I'm gonna check real quick if I have like any thick-ish piece of material that I can put under the aluminum. Actually, echo should actually be pretty good here. What can I mount this to? I'm guessing if I just grab another piece of OSB. I mean, it's something. It's like a bit of help, maybe. Does raise it up ever so slightly. The only problem that I found with this mic is that it's somewhat sensitive to wind noise. So if I walk around, it does like to pick up some extra wind. So let's do that. It just adds another, I don't know, this is an 18, I think. Does add a bit of extra height. Maybe that's going to improve the chances of the aluminum cut going well, but we'll just have to see. Yeah, let's use these 4x40s. Oh, stay here. These aren't 4x40s, these are 4x35s or so. Where's my bits? There's my bits. Go as high as you can, or you could go directly to stainless steel. No, guys, we are not cutting steel today, and we're especially not cutting stainless steel today, because that's an absolute horror to cut. Just everything needs to be perfect for stainless to work. And I don't think we're at that point yet. All right, so that cool. We just perfectly dropped the 3D lac, and it's still standing. Nice. So that's that. Now the piece of aluminum. There are a few ways that you can mount stuff onto a flat bed. Like you can tape it down, you can clamp it down with a vise, or you can screw it down, which I think for now is the most secure option, since we are kind of worried about this stuff holding down properly. So I'm gonna start, or I'm gonna just drill a few holes through this and just screw it down as well, just like the other bits. Machine isn't working in wood. I mean, hey, we cut wood, right? The wood cut. It worked. It did cut. So one there. One there. And one more there. All right, and that should be good with 3 screws. Double-sided tape would be better. The reason why I'm not using double-sided tape, now I could combine this. I could put double-sided tape under the screws and and screw it down as well. But the reason why I'm not using that is because the double-sided tape that I've used before tends to get weaker or softer as it heats up. And I've had enough parts come loose on me during cutting because the tape just did not hold up. So I don't want to risk that. I'm just going to screw it down real good. And that is, I mean, this is also the most rigid option of mounting stuff. Because this is not going anywhere. I can move the entire CNC around on that piece of aluminum. Okay. Use painter's tape on both board and piece. Super slow plunge rate. Yeah, are these Phillips screws? These are the only the only panhead screws that I could find for this build, because I didn't have enough of those and I had to get them locally, and that's what they had. So too bad. All right, super slow plunge rate, super slow everything. Let's just go super slow. Let's try at least. So the cutting parameters that we were using in ESTLCAM, in ESTLCAM, were basically, the ones that all the calculators and all the stuff said to use for aluminum. So 600 millimeters a minute. That comes down to feet per tooth of, I think, 25 micron or so. And then the Z step down will reduce that. We'll reduce that to. I feel like I don't want to go lower than a millimeter. Super slow plunge rate. So let's go down to 60. So that's 1 millimeter per second. Still sounds rather quick. Let's go 30. What I've also noticed with the plunge, while we're talking about plunge rates, let me see if I can home you guys in on that. Right there. You guys see the lead screw. You also see the nut for that. Now the instructions said not to tighten these 4 screws that hold the nut in place. So if I lift, you guys can see that, right? As I lift the tool, you can see that the nut in here, the bronze nut, actually lifts inside the part. So this is not screwed down totally. This still has a lot of air in there. So yeah, I don't know. One more thing you guys were saying is use a single flute end mill. So let's use a single flute end mill. I do have these really nice and sharp end mills from hi chat from CNC the CNC guys. They sent me these. These are unused so far. I've got two. So this is a really nice polished single flute end mill that they said works really well for aluminum. I'm going to be using this for this cut. So yeah, let's hope it goes well. So this is going to go in the spindle. Let me just place this on our workpiece so we don't forget. If that bit doesn't work, then I don't know what will. If I snap it, I've got a second one, but I hope I don't. So for our piece that we're going to be cutting, let's cut something else because we already have a crown. Let's do the motor mount. Wow, fantastic DXF, Tom. Great CAD work. So this is just a Fusion 360 sketch that's been exported. Now I'm going to do the same thing. Well, actually, let's start with this. Let's do a very, very simple cut first. There's going to be a pocket. No, we're not going to pocket that out. Where do we get the... Oh, no, I don't want to do a cut. Hold up. That's wrong. Where's my select? There's my select. I don't want to do a part. I want to do a hole. Let's just do a really simple hole. Let's do this. So basically, these four corners are going to be these screw positions. Then we have a contour, and then we have two more interpolated holes that we can try. So we're going to try that just step by step. We're going to do one feature, see how it goes, and then do the next feature. Because our home position is not going to be moving around on the machine. The machine is going to remember where it left off. Because of that, we can move around, or we can move around. We can do one feature, look at the part, look at the cut, then do the cam for another feature, and then yeah, keep going like that. So that's literally all we're gonna do. So 1/8 inch end mill, 1 millimeter Z cutting depth. I do wanna go in a bit more shallow, maybe at 10 degrees. 600 millimeters is a minute. Because we're using a single flute and not a two flute, because we're using a single flute, we should reduce that to half at least. What do we... Oh yeah, let's call this one single flute 1/8. So yeah, that's all good, that's all good, that's all good. Okay. So let me save. So that's going to be the 22 millimeter hole. Save cutting depth. That's a 6 millimeter material. Okay. And what we're doing is almost a spiral cut. I think it's totally just a spiral cut all the way down. So there's our 0. It's going to move up quite a bit. And then do a 22 millimeter hole. Okay. So back to this job status. It's good. G-code files. We need to upload this. Close. There's a 22. Do we want to run? Not yet. Let's change the bit. Actually, we need to cancel out of that, because we do need to move up a bit. I may have moved up too much. Stop. 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 Caught it. Caught it on the last, well, on the very last bit of the of the tubing there. Thankfully, there's the emergency stop option. Go down a bit more there. That's safer. and swap out our end mill with the correct one. Put a screw through the waist. The waist board has 4 screws through it already. It is clamped down quite well. Yep. Always 2 flutes. Ha ha ha. Good thing that chat is kind of... Everyone's saying something different, as always. I'm just going to use this one end mill. That looks okay. Always 2 flute for aluminum. I mean, there's really no reason why it should always be 2 flute. It just depends on what machine you're using and how rigid it is and which end mill works best for your setup and your material. You can cut most stuff with 4 flute or a single flute, and really it just depends on your cutting parameters. You can make anything work. Nope, wrong axis. So let's go a bit further forward. Like there. Okay, and let's move down. Let's try not to crash it into the part. Just gonna leave the Okay, right there. I'm just gonna leave the protective film on and set this to 0. 0, 0, 0. That's where we need to be. That's gonna sound amazing with the headset mic. Yeah. All right, let's try this. Always have the spindle on when zeroing. That's probably a good idea. I'm kind of nervous. I'm gonna turn the vacuum on as well because I don't want to get aluminum swarf all over the place. I may be making like beard noises on the mic. Please excuse that, but it's going to be noisy anyways. Safety gear, I've got my glasses on. You should probably be wearing a face shield if you're trying this stuff. I don't want to grab my face shield right now because it's going to mess up a whole lot of stuff. But guys, if you do something like this, especially on the new machine, be safe. All right, 22mm hole. Yes, let's go. Okay, that plunge. No, 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 no. Nope. 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 I do not like that a single bit. Nope, that's not happening. That is 100% not happening. The bit is still sharp. The bit is still good. Because again, this is only aluminum, but nope. 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 Let's get you out of here. Way too deep? Guys, I wasn't even scratching this stuff. So that was barely 0.5 millimeter in. If I switch over here. Come on. So you can probably see the swerve that it kicked up, but this was like half. So we were doing a 1 millimeter depth of cut, which means once it does a full circle, it's at 1 millimeter. So up here it should be doing 0.5 millimeter, and that should definitely work. Just too fast, too deep. Just feed rate slower. The problem is end mill way too out. What? Slope that it's at a 10-degree slope. The problem is that if I actually set this to be a really slow plunge, it's just going to take forever, and the bit is going to be most of all rubbing. So what I don't want to slow down the feed rate, because we do need some, especially on these weaker machines, we do need some cutting, some force on the bit, or otherwise it's just going to be rubbing against the material and then taking a cut and then rubbing again. So that's not going to work for sure. What I can see working is going with a lower depth of cut. Just, because it did work fine up until, so let's say this is, it did plunge in a bit. Let's just go to 0.3, and that should work. If you go to 0.3 millimeters, it's, the problem I still have with that is that it's only really using the very, very tip of that end mill. It's not using, this has a 12 millimeter cutting fluid. It's just using 0.1. So you're throwing away basically 95% of that end mill. You're not using that sharp edge. You're just using the very tip, and you're just wearing that down. And once that's worn down, your bit's life is over. So, well, let's try if you can make it work. So where's our cutting angle, our plunge angle? Let's slope that down to 5 degrees, and let's turn that down to 0.3. Right, and this one on that end mill. Wait, did it have? No, but that, oh. It may have been, yeah, because it did plunge. It may have been on the wrong end mill, but still the cutting depth was on 1 millimeter. The only difference was the feed rate. Okay, it may have been on the wrong bit, but let's try again with 0.3. So 22 millimeter hole 2. Whew. G-code files.
No guts, no glory. Perfect. Here's to replace a snapped end mill. Smiley face.
Well, that text-to-speech is rough, but thanks for the $10, Auntie. End mills. And those $10, if I can make the cheap end mills work, then those are gonna buy quite a few end mills. So thank you for that. There, and then Z. I will try to cut. Yeah, I will try to cut almost the same hole again. That's 0. Now there are options to run or to control a CNC machine with like an Xbox controller. I feel like that would be kind of convenient, but I don't have that set up right now. But that would be nice. I can see how that would be super convenient, at least for setting the home position. Other place. So the problem I have, and I guess this is the only camera that can show it. This is the flange right here. If I actually move over to this side, then the part's not going to be on it. So I'm not going to create a usable part. This is going to be the most usable. This is going to work. So, There we go. Let's retry. So we are at 0. We are home. We have the right G code. We have the correct end mill. Let's actually double check. Yeah. So select. We did have the correct one selected. That's good. And we do have the correct G code. I look like a helicopter pilot with the headset and the mic, I think. Ridiculous. Yeah, and we do have, it's 78 kilobytes, which means it's doing more cutting, which means there's more G code in there. So same geometry, but more lines means less material per line, at least roughly. So we are ready to cut. Let's try again, and thank you for the $2, Alex. Whew. That's gonna buy 2 more end mills. Nice. Headphone users, I'm hoping it's not gonna be too loud with this mic, but I mean, let's try. Yes, and my mouse is hovering over the E-stop. Okay, so now it's doing the angled plunge. That's chatter. Oh, it's ever so slightly chattering. So let me turn down the speed to 64%. Too slow. Ha ha ha. Of course, the tool load isn't consistent or isn't constant here because we are kind of running over a previous cut. Looking at it from the top, it does look okay. Like, it does look like it's cutting. You can see on the side here that it is creating a rather nice cutting surface. Smooth, chattering. Really bad chattering. And now it's good again. So I actually do not know what is up with that. I mean, the cut, what I'm hearing through my earmuffs, it doesn't sound all too good. And this doesn't sound good either, like not at all. So what I'm gonna try on the next round is I'm gonna try to bias this thing with my hand, just kind of giving it a bit of a push in one direction, maybe to dampen it, maybe to pre-tension some bearings. I'll just keep my finger on here and see if that improves anything. That's making it worse. Ow. That is making it way worse. Okay. I shall stop this job. Turn off the spindle. Show you guys my finger because I just
so much of your stuff, my son. 3 calls you Drucker Pepper.
I'm going to show you my thumb real quick. Have you ever seen like molten plastic on a thumb? Come on, there. I'm not going to show that too long. I just reached into the brim of this fan, which apparently does burn you pretty badly. Ow! So there is now an interesting burnt line on my thumb. Fantastic. Guys, I'm going to call it a day for now because I'm already at the point where I'm getting hurt and I'm at the point where I don't think this machine is going to be cutting aluminum. Yeah. Something is... Yeah, so the motors are powered down right now, so this is moving. But this is not as rigid as I was hoping for. Not sure if it's the belts or if it's the printed parts or something else, but yeah, that's going to be it for this series. Actually, we did cut wood somewhat successfully. We did cut this thing pretty well. I think it turned out for an HDF part. Did turn out fairly well. But yes, thank you all for following along on this journey. Just want to shout out Alex and Puckstardoc for these super chats that just came in. And thank you everyone who followed along with the process, who gave tips along the way, who was helpful. That is much appreciated. And yes, I hope you learned something. I hope if you're going to build an MPCNC like this, it makes your life a bit easier just having seen the entire process and seeing what issues can come up. I'm going to put some ice on my thumb because this thing is starting to hurt. Have a nice evening. Have a nice day, everyone. And I will see you in the regular videos back on this channel. Get subscribed, joining on the YouTube memberships, joining on Patreon. If you feel like this was nice for you, it was nice for me, for sure. But yeah, goodbye, everyone. See you soon.